All right, so writing function rules from equations. So this question, the way it's set up is a little bit weird if you're not used to it. It's completely appropriate, obviously, but if you're not used to how it's set up, it's somewhat difficult to understand what to do. For the given input value b. Now, if I have, say I have y equals x plus 1, my input value would be whatever I want it to be. So if I'm on a graph over here, I just need to know, okay, at this x, which is 1, what's y? So I can make a dot, right? So if I plug in 1 here, 1 plus 1 is y, and y is equal to 2. So when I plugged in 1, I got 2, so it makes that point. So at 1, I'll go up 2, and that's where my dot is. And I could do 2 plus 1, so at 2 it'll give me 3, and just make my dots all the way up. That's how the input value works. The input value that they want you to use is b, so that's the one that you have to leave in the equation. Now it says for any given input value b, the function f outposts a value a to satisfy the following equation, which basically means if you know what b is or you have some that you can substitute in, it can help using this equation and making it true will give you the answer. It's essentially standard form of linear equations, whatever. But if I can figure out what this equation looks like where I'm just trying to find, okay, get a by itself, then I can work up the number that I want. So if I have 4a plus 7b equals negative 52, what I need to do is figure out, okay, if I have b's that I want to plug in, what a value do I need to have there to make it balance out, that sort of thing. So I'll do, so pick the value they're not talking about in terms of, and put a little highlight marker next to it. That's the one we want to keep. Everything else we're going to move. So the first thing I need to do is get rid of the, on the same side of the line, the furthest thing away, which would be 7b. So I need to get rid of plus 7b, so subtract. Those cancel out, and I get negative 7b minus 52, and then bring down 4a. In this case, all I need to do is get rid of times 4a, because that's the only thing with a, right? So I'll divide by 4, because that's the opposite of times. So I end up with negative 7 over 4b minus, and if you do 52 divided by 4, you end up with 13, so minus 13. So this is my answer that I need to plug in. So I go up here, I'll type in, I'll pick that I want to do a fraction, I'll do negative 7 over 4, and then click out and pick my variable b, and then I want to do minus, and you can either use this or whatever, 13. And then check your answer, and there it is. One more. So in this one, they want it in terms of m. So what I need to do is make sure that I get my n all alone. So I'm going to take my equation here, write down negative 2m minus 5n equals 7m minus 3n. And I want to get the ends, oops, highlight, ends together. So since they're on opposite sides of the line, it needs to be purple, I'm just going to move them together. On this side, it's minus 3, so to eliminate it, I just do plus 3n, plus 3n. I end up with negative 2m minus 2n. So here's the case. I'm still trying to get this all by itself, so it could be left alone. Get rid of minus 2m and add 2m to do that. (9m). To do, what do I need to do to get rid of times negative 2? I just divide. N is equal to negative 92 over m. So let's go over here. Negative 9 over 2 times m. And there you go. So that's really all you're doing. Pick the variable that they don't want to know about, highlight it, and then just move the equation around until you get it all by itself, and then you just type it in. It's not the easiest thing in the world to do. In fact, I'll just do one more just for funsies. In this case, negative 5x minus 4y equals negative 8. They want it in terms of x, so that means they're trying to find y. I need to get rid of this entire term. It says minus 5, so I'll do plus 5. Always read the signs in front and nothing else. These are not like terms. 5 divided by -4 is -5/4. -8 divided by -4 is +2. And those cancel, I just end up with y. -5/4 x plus 2. There it is. Writing function rules from equations.